So for day 15 of Advent of Code, we're building a warehouse system. Basically, we're given a layout of a warehouse and we need to move our robot through the warehouse based on the given instructions. And this would be easy if there were also crates that we have to move while moving the robot. So there are these crates marked by O, which the robot is moving as it moves. And when it hits a crate, it moves the crate in that direction. And if there are multiple crates, it moves those multiple crates until it hits a wall that is kind of solid. It cannot be moved. So we need to kind of simulate the movement of the robot through the warehouse and moving those boxes throughout the space. And finally, when it finishes, when we process all the commands, we will have to figure out what's the final arrangement of everything and see what is the total of coordinates, where we take 100 times the y coordinate plus the x coordinate. So that's what we are doing in this puzzle, and we will be trying to figure it out. So let's take our sample input, which is this. So this will be mainly about simulating the movement of a robot. The big input is not necessarily that big. It's like a lot of instructions, but the map itself is not that huge, so it should be okay. So we just need to figure out how to simulate it properly. So let's have map lines. We'll have map lines. We'll have some private int width and private int height, and we'll have a map which will be car map, and we will be reading that map. So while string is empty or white space line. So this will be reading the map first. So we'll add to the map lines, and when we finished, then we have width equals the length of the first map, and then we initialize the map, and for y to height, for x to width, we will read in the map. So xy, appliance yx. So this will read the map this way, and then we need to read the instructions, and the instructions are on a single line or is it multiple lines? It's probably multiple lines, it seems. So let's check that. Oh, we can ignore the new lines. So we'll have some kind of string, a string instructions. Those will be the instructions. Or rather, let's do it as like a string builder. Oh, instructions. So we'll read the instructions here. So while line, we'll read the line. So what I basically I just do the string builder. And finally we put it there. So this is reading the input, and now we will be processing the instructions. So what I will do probably is to store the coordinate of the robot. Point robot position, so that I can easily move it. Move robot. So that's down here, and I will do private void robot instruction. Now we have the robot, and the robot will, you'll check where it is. So if map xy equals, and that's at character, then the robot position is that. Okay, so we now know where the robot is, and we can move it continuously. Now, when the robot moves in a direction, we need to check if that direction, in that direction there is a dot. So so the characters are this. So this is west. South is E. East is this, and this is up coordinate. So we will read the directions, and now based on that we will get the next position. So now if the new position, and we don't have to check boundaries because the boundary of the map is always like solid, so we don't have to do anything there. So if new tile, let's do it. If the new tile is a wall, we cannot move at all, so that's easy. Else if new tile equals dot, if it's an empty space, we just move the robot there. So that's very easy as well. So dot, and new position is robot position, and we update the robot position with the new position. And we can do it at the end, I guess. Yes. Actually, we can do the whole thing there. So if it's a crate, which is this, then that's going to be interesting. So if we need to check if we actually can move in that direction. If all the boxes in that direction move and don't hit the wall, then we can move. Otherwise, we cannot. So if can move, so can move boxes, new position, can you box that's on the new position in that direction, then we move box new position direction. So essentially we will first check if we can move the box, and then we will move the box itself. So the private void can move box, and this is going to be a method that will check recursively if it can move And if it cannot move to that space, it will check if it can move the thing that's on that space. So essentially, we are looking to replicate this just, well, essentially it's going to be the same thing as here, right? Well, essentially we can do, what we can do is if can move robot position direction, and we will move the robot, then it means that this whole thing can be moved there. Except for this. So we can do position direction. The thing is that we will be, when we move this, then we also update robot position direction. We update the robot direction position. So now we implement this part. Move. So we get it to the next position. If it's else if new tile equals dot, then we just can move. That's okay. So we can return can move here. So recursively we're moving the next box and return false so we're moving from a position in a direction, and we can move if there is not a wall, or if recursively we don't hit a wall going forward. So this is the logic that will check for movement. So this should never happen. And then finally we do the movement itself. So if the new tile is a dot, then if it's not a dot, then we need to move that next position as well. And finally, when we are done, we'll move the thing that's on this position. So we will have position X, position Y equals, well, new position equals and we will just replace the current thing with a dot. So we basically move that thing that was on this position to the new position, and we set the current position to a dot. So if this seems to make sense to me. So we'll see if that's correct. So we can actually return a string builder, or rather we can do for debug right line, right, debug right line, just to see how it looks when we are done with this. Okay. It seems to make sense to me, at least. I don't see any apparent issue with the code. And hopefully the recursion shouldn't be very slow. So just return this for now. So yes, let's see what happens. Right, so we have day 15 here. With this data, and the final state is the following. Let's verify if it matches what we expect it to look like. And then that seems at least reasonably, yeah, it seems the same. So now we just calculate the positioning. So this position will be so if map x, y equals, what is the map? If there is a box, then we calculate total 0, and the total will be total plus equals y times 100 plus x, and finally we output return total to string. Hopefully that will be it. Well, 10,092, which is correct. Okay, so let's take the full input and then we try to run it with the full input. And it's this. Let's confirm. And that's correct. All right, so we have the first part solved. Now continuing to the second part. Right, so there is a second warehouse robot, but the warehouse layout is very similar, except for everything is twice as wide. And the list of movements doesn't change. So it's just wide. If it's wider, then each hashtag tile is now 2 hashtags. Each O tile is now like this, and this is now 2 dots, and this is now add and a dot. And the boxes are twice as wide. So the boxes can be lined so that they directly push 2 other boxes. So it's now like we can push these 3 at the same time, basically. Yes, so the robot can push them all at the same time. Yeah, all right. That is reasonable. So it should be just not trivial, but not too complex adjustment to our current solution. So let's put it here, and now we have to adjust the reading of the map. Because everything is twice as wide, it's going to be times 2. Character, if it's character, so if it's at position, then so if it's at, it will be times 2. The initial position will be x times 2 y, and map. Well, I mean, if character is at, then a map x times 2 y equals at, and map times plus 1 is dot. else if character is this, then it's both, yeah, duplicated, and else if character equals this, and if character equals, oh, then it's gonna be not this, but this and this. And we have to fix the coordinates here because that's not correct. This is correct. So that will read on the map, hopefully correctly. Now we need to adjust our logic for movement of the robot. Why is he complaining here? Yeah, because I didn't close this. Right, so now we have to move the robot based on the instructions. So the width will be twice as wide. Actually, we should be doing this, right? Because we are moving across the line, but duplicating what it contains. So that's more correct now. Right, so what we can do, we can actually confirm how it looks. So just to make sure we don't have some mistake there, I will do right line, right XY, debug right line, right, like that. So let's just confirm that this correctly looks like the problem that we are solving for the test input. Okay, let's right here. Now we do part 2 and test data, and we should have this. So yeah, does it look like it? Seems to be okay to me. Yes, looks good. So now we do the movement itself. So so now the logic itself, that's going to be more complicated. So if the tile is if the new tile is a wall, then we can move. That's the same as before. If the new tile, now this is going to be interesting. We need to make sure that the new tile is dot and we return true. And now if we are moving, okay, so current tile. If we are moving the robot, then it's basically just checking if we can move the next position. But if the current tile equals this and direction equals, we have to figure out how to move the box, like So if we're moving to the left, if we're moving a position to the left, and the position, the tile is this, and direction is -1, 0, then we just check if we can move the next part of that box, the left part of the box. If the current tile is this and we were moving to the right, then we check if we can move the right part of the box. If the current tile is okay, so basically we can do -1 direction, minus direction. So right of resurrection. All right, okay. So we can simplify this. So if we're moving this or this, then we check for the movement of new position plus direction, one more in that direction, because then the next in the direction would be the second part of the box. If current tile if that's not the case and the direction is +1 or direction is -1, 0, then it's just checking if we can move in that direction. Finally, if direction is vertical, then it's going to be more interesting. So if direction, if current tile is this character and direction is -1, if you're on the right side of the box and direction is -1, then we, or rather, if it's -1 or +1, +1, then we need to move the two parts of the box. Both have to move. So return can move new position action. So the thing that's directly above us, and also can move -1. So the left part of the box has to be able to move as well in that same direction. And else if current tile equals left part of the box and direction is vertical, then we have to move the left part of the box and also the right part of the box in that direction. And then I think this should never happen. This should never happen. We should never get here. We should be exhaustive in these options. So horizontal are counted for, vertical are accounted for. So I think this should be enough. So we'll see what happens if it's really the case. And now the movement itself. So we know that we can move. So we need to move the positions themselves as well. So the current tile. So if it's not a dot, then we move the recursively that position. Right, I need to figure out how to move this correctly. So if current tile, like if the new tile is not dot, then we have to move the next tile. If current tile is add character, we can just move it afterwards. After that new position is emptied, we just move the robot to the new position. If current tile is a left part of the box, so if new tile is equal to left part, okay, so let's think about this. So if the direction equals -1, 0, so we're moving to the left, and new position, new tile equals this. So we're moving the left side of the box. Then we will call move position plus direction direction. So that will point to the left part of the box. Then we have if direction equals +1 and the new tile is this, then we move into the right side of the box. So these are basically the same thing, right? And actually, the same thing is here as well. That's exactly the same thing. So we can just OR this one. So we can move in that direction. If the direction is vertical, and new tile is this. So if we're going vertically upwards and we're hitting right side of a box, we'll move Well, actually, it's gonna be easier because we don't have to care about the boxes themselves, right? We can just move their individual parts one by one. So that's actually easier, right? So we can move first this one, and then we have to move new position in direction. Is that right? If we're moving to the right or left, we just move everything character by character until we hit the wall. So until we hit empty space. So if direction is -1, -1, 0, or direction is 1, 0, we just move to the right horizontally, and we don't care about anything. So if the direction is horizontal, then if new tile is not equal to dot, we just move the position, and when we moved, then we move also the thing that was there on the map position, or our current map position. So the horizontal movement is super easy. Yes, that is okay. And now if else, so this is vertical direction. So if it's vertical, then we do care about what's where we're going. So if a new tile equals this, or new, if we're moving vertically towards this character, we have to move both that character direction, as well as we have to move new position +1 in that direction. Else, if new tile equals this, you have to move new position direction and new position -1 direction. And if it's normal, if it's anything else, we just move. Else, if new tile is not this, then we move to this. So that should be it. Finally, we can move. In both cases, we can move whatever was on this position to the next one. And this seems pretty good. So now let's see if this is actually a correct solution. I will, just to make sure, I will move this here. So we have the debugging again. But it feels correct. So index out of bounds array, whether we hit that. Index out of range. Somewhere we're hitting that. Okay, so we're moving. The map is too small. Right. That's here, somewhere here. We're creating the map too small or something. ×2 is just okay. Right. First tag where we are 12, 1. $19, $16. Ah, right. If it's... Oh, it's trying to move... it's trying to move into a wall. So something wrong if the logic inside the can move, right? So something is there incorrect. It's moving position of robot 13.1, direction to the right. And it evaluated it can move there. So let's actually try to output the map in that position. I'll just make a method for it. Map. And we'll put it there, and we'll just do something like this. So we output map every time we are allowed to move. Should hit the exception, and we will see what state it is in. Oh, we do something wrong there, definitely. We create some invalid movements. Right, so let's go back and let's see whenever we start doing something wrong. So I'm moving to the left, or yes, to the left, and we destroy the brace there. Over on the first move, actually. Yeah. Right. The reason is because I'm moving it in the incorrect order. So I need to first move the brace on that's farther from me, and then the current one. So if this data, and this is still wrong. Still something's wrong. Okay, so right, let's see. Still moving incorrectly. So if we are moving horizontally, right. So if it's not, this is not right. We need to, I was moving only the next step, not the current one. So now it should be better off, and it seems to be moving more reasonably. And this is nice that we can actually see how the map is changing as we're going. And so far it seems like pretty logical movement. Nothing too weird about it. Yeah, that's pretty nice. Kind of an animation that's happening here in the output. Yes, and moving the boxes even vertically so far is pretty promising, but here we have a problem. So, where are we? It evaluated that we can move to down direction from here. So 12, 13. So we're on 12, 3 and want to move downwards. it definitely cannot move that way. 12, 3. So let's put a breakpoint. 12, 3. And let's stop this because we know what's happening there. And let's run it. Something in the vertical movement is still not correct completely, so you have to see why. So we're going down. The new tile is this, and yes, so we're trying to move. And oh, wait. Ah, that's right. All right. Okay, so this should be before. Yeah, because yeah, right. Because we're not checking. If we are moving if we're moving a box, we have to process that first, and only if we're not moving a box, then these rules apply. The simple rules apply only if we're not moving a box. So the order needs to be like this, and we have it reversed. Right, so test data, and still not there. All right, so okay, so right. And now a little more adjustments. Current tile is this. So these rules now have to apply. All right, maybe let's do it like this. If current tile is this, or current tile is this one. So that this logic happens only if we're moving a box. Right, so right, so this rule is now superfluous because we know that so it can be return can move new position direction. So this is the right logic, I think. So now we're moving if we're moving the box, we process these special rules, and if none applies, then we just do the classic movement. And we have this as the fallback for other cases. So if I'm not wrong, this could be right. And it's not. Okay. Shoot. What is this situation here now? Map is 21. So we're trying to move into a wall, and position. Direction is +1. Current position is Y. Position. Why is it? How can we be on? Wait, I'm mixing up the positions, I think. So if we're on, if the current tile is right, removing left, we are checking this. If it's left and right, we have to check if the right part can move. And the right part is the new position, basically. If we're moving up and we're here currently, we have to check if new position can move, and new position -1 can move. Wait. Am I missing something here? No, this was wrong. That's for sure, but it still doesn't explain my index out of bounds for the vertical movement, because that still happens, and that happens here because we are on new position. The current position is 10.8. We're moving to 10.9, but also because it's this tile, 11.9 is moving upwards. (11.9) is moving upwards. Oh, well, this is completely weird. How can we be there? I have to run this again. It seems like there is something wrong in the logic completely. So we're moving downwards from here. The current tile is the robot is on 10.7. 10.8. Robot is on 10.7 and it's moving to 10.8. 10.8 is not. How can 10.8 be? What is this? That is weird. The robot is. here. And it's moving downwards. So why is it hitting 10.9 is not a 10.9 is not there's a dot? No? How is there a comma? Now I'm very confused. So new recurrent tile here wait. Right. If we're checking if we can move right, so order of the logic. If new tile is
Someone's at the front door doorbell.
Sorry about that. If the new tile is a wall, we cannot move, that's for sure. If it's a box, then we move the box. If it's something else, then we solve it here. This should be better. Okay, this took a while, but I think that I found the problem now. Right, we're moving logically so far. So far so good. I think it's gonna be okay now. Just comment out our output because this is hopefully no longer needed. And if everything went according to our expectations, operations not valid. Okay, so we're still not there. All right, this is it's getting long, right? Invalid operation exception. So missing something more here. The current tile is a dot. How did we get there? From here. Right. Yes, of course. So what we need to do is also, if we're currently on well, this should be okay, but it's not beautiful. It doesn't make too much sense there, so that's why we need to adjust it. So 0, okay. We're moving. What's happening there? Data. How does the map look like? And yeah, we need to now figure out the value because there is no O's there. So GPS coordinates of the boxes. So we now check for the left brace. $9,021, that's good. Now let's try the big input file. And that should be here. So, okay, still something. What is happening now? We're trying to move a wall. So current tile equals hash or new tile equals hash. Then we cannot move. This is not right. This is not great. It's like the logic should be broken down a little bit because yeah, so this is the result. And it is correct. That's true. But what my problem was that we're checking for like this logic here is completely independent from this one. And we should be checking. We should be checking if we actually can even call this based on what's on new tile there. So if there is a wall directly, we need to make sure we don't even go there. This works, but it's not a beautiful thing. But it could be refactored. But as long as it works, I guess it can be okay. We are already a little bit over time, so I think we can pronounce this as solved. I might refactor it and push refactored version into the repository, but I mean, the logic makes sense. It just didn't came out as succinct as I wanted to. But anyways, I hope this was at least useful for inspiration. Maybe you can write it more succinctly in your solution. But we have solved day 15, that's for sure. So now we have another gold star. And I will have now 3 days of vacation, so I will not be making videos. So on Thursday I will be back, and I will try to catch up at least a little bit, like 2 problems a day, hopefully, or something like that. We'll see. So I will see you on Thursday, and also check in for my second video to see if ChatGPT can also solve this problem. So have a great day.